All right, welcome. Good morning. We're just going to give it a few minutes to let some more people trickle in, and then we'll get started.
While we're waiting, it is National Dad Joke Day. So if you have any good dad jokes, you can put them in the chat for the Q&A.
All right, well, I'll kick things off. Good morning. Happy National Dad Joke Day, like Lauren said, and welcome to the StackHawk and GitHub CodeQL webinar. My name is Nicole Jones. I'm a marketing manager here at StackHawk, and with me today I have Lauren Nagel, our VP of Product, and Zachary Conger, our Solutions Architect. We're super stoked to have you join us this morning. This is the first time we're showing off the new integration with GitHub CodeQL. So we're going to keep the slides short and sweet, give a little background and high-level overview on Datast and StackHawk, SAST and GitHub CodeQL, and how Datast and SAST work together to create a really cool, complete set of security tools for your applications and APIs. So like I said, we'll dive into seeing the integration in action pretty quickly, and then we're going to save some time for Q&A at the end. So drop your questions, comments, dad jokes, whatever you've got in the chat or the Q&A in Zoom, and we'll run through those at the end. So over to you, Lauren.
All right. Well, being that it's National Dad Joke Day, we have to kick it off with a dad joke. So where did all the security testers go? They ran somewhere. All right. And that's the explosion that happens after security issues and people run away from it. So anyways, next slide, please, Nicole. Just had to kick it off with a little fun. So I started my career as a QA engineer, and we were always taught that the earlier the bug is found, the cheaper it is to fix. The closer you get to code releasing out to production and to customers, the more disruptive and expensive it is to address those bugs. So the same is true for security vulnerabilities and issues. And we can see here that the cost actually even doubles just from that one step before you hit production. But despite that, most security issues are found after they're in the wild. Either they're found during some sort of audit by a security team against production code, or they're found, by a potential hacker. So you don't want those to happen. If they're found, even if they're found by your own security team, in an audit, then they're thrown back over the wall. It disrupts existing product development and roadmaps. Developers have to go back and look at code that maybe they haven't looked at in months, or maybe somebody else wrote and the person that wrote it isn't even there. So it's just so much more disruptive and expensive when you don't find those bugs earlier. So our goal at StackHawk is to give developers the ability to find, prioritize, and most importantly, fix those security bugs earlier in that software development lifecycle. So while developers are still actively working on the code before it might be released to production and be a potential vulnerability and cost to the company and your customers, and before it's too disruptive. Next slide, Nicole. All right, so how do we do this? The ratio of AppSec to engineer teams is only 2%, which is really small. So that means you can't do this by yourself with just an application security team. All you can do with 2% is some firefighting and some production testing. So you have to leverage automation, you have to leverage dev tools, and you have to leverage other teams in your organization to have truly robust security. So StackHawk creates this force multiplier effect by turning your developers into their own security testers with a tool that's purpose-built for them to use in their existing workflows. So we give developers and engineers all sorts of tools to find errors and bugs. We let them know when they write code, if the syntax is wrong, it won't compile. When they merge code, they know there's a problem if it doesn't merge correctly. When they run unit tests, it tells them something's wrong when the unit test fails. And then when they run integration tests, they see it doesn't work as it was designed or per the specification. But when they introduce security vulnerabilities, right now there's nothing that tells them, hey, you're introducing a security vulnerability. So we need to make sure that we're giving them tools to test security the same way that they test all the rest of their software, running their unit tests, running their regression tests, doing a compile. This should just be, security testing should just be thought of as a normal part of their software testing. So how do we do this in the CICD build cycle? So the CICD build cycle came about because we had to keep up with rapid releases. We didn't have time for waterfall anymore. We wanted to be more iterative. We wanted to be more responsive to customer needs and to feedback. And so CICD allows teams to find and fix bugs earlier and ship better code. But again, application security testing remains separate from this rest of the software delivery cycle. And where historically we see the security testing is, again, after that deployment in operation. But that's where we've got this big red circle. We don't want those security vulnerabilities to make it to production. So what we're able to do with SAST and DAST testing, which is what, so StackHawk is DAST, GitHub CodeQL is SAST, and what this enables us to do is move that security testing into the code, the build, the test, and very lastly, right before that release and deploy part of the software development lifecycle. So this ensures that, again, those vulnerabilities are found when they're easiest and cheapest to fix before you've exposed your company and customers to security concerns, and when it won't be super disruptive to then run an audit and throw a bunch of old security vulnerabilities back over the wall to your team. So Zach's going to take us through a little bit more about what DAST and SAST are, and most importantly, what you've all tuned in for, what does this integration do? Why is it so important? Why are we so excited about it?
Thanks, Lauren. Okay, so let's start off with SAST. So this is what CodeQL does. What is SAST in the first place? SAST stands for Static Application Security Testing. Some people call it static analysis for short. And what it does is it takes a look at your code base and it tries to crawl through your code and look for dangerous patterns, potential vulnerabilities, code smells. And it tries to pinpoint any issues that it finds by line and file. So it's really powerful for developers to use as a tool to identify vulnerabilities because it points them to exactly where the problem is. One of the problems with it is that it can tend to be high in false positives. And it might be unfair to call them false positives because the things that it finds typically really are vulnerable patterns and you should address them. But you might not want to prioritize them if, in fact, they don't result in an actual exploitable vulnerability in your running code. CodeQL as a tool is a particularly attractive choice for a lot of people because it's so easy to automate. It's built into GitHub, and it's literally a push button operation to add it to GitHub Actions, which is GitHub's CICD utility. And it's able to rapidly scan many popular languages. So it's a really simple thing to add to your build pipeline, and it gives you a lot of great information about your code and where to find problems, potential vulnerabilities. Next, there's Datast. So StackHawk does Datast, and what is Datast? Datast is dynamic application security testing, and some people call that dynamic testing for short. And what it does is you bring up your application, say it's listening on an HTTP port or an HTTPS port, and the scanner will actually attack that application. It starts sending in malicious inputs and is looking at the outputs that the application sends back to it. Now, it looks at those outputs to determine if it was able to successfully exploit a vulnerability. And what you get from that is reproducible evidence for vulnerabilities that are found in your code. And a huge advantage of this kind of tool is that you've got that evidence, you can recreate that attack, developers can reproduce the attack. It's a great tool to have when you're trying to troubleshoot and fix those problems. One problem that it's got is that it doesn't know anything about the language that you wrote it in. You could look at that as a problem or an advantage. It means that you can scan any kind of application that listens on an HTTP port, but it also means that we don't have insight into the code within the application. So we can't point you to the exact file and line like SAST can. When people hear Datast, some people who have familiarity with Datast may think, well, that's not something you can automate into a pipeline. And that's because back in the old days, back in my time, there were expensive, clunky applications to work with, totally GUI driven, really heavy, hard to install, hard to manage. When they do scan things, they just scan at a snail's pace. And as a result of all of that, they're typically not automated. They're run only periodically and manually. And what you end up with is these periodic, not very frequent scans, and you end up with a ton of vulnerabilities that they may have found after the code is already in production, where Lauren just told you that that is the most expensive and problematic place to try and resolve a problem when you've already released that code to production. Now people are dependent on it. You're sort of into that code base. The developer who worked on it a long time ago. They're no longer in the headspace. I don't know about you, but I forget the code I wrote 2 weeks ago, let alone 3 months ago. So that's what StackHawk has tried to address with our utility. So with StackHawk Datast, it's totally developer focused. It's meant to be used and operated by developers in the day-to-day. So that's why we've got configuration as code. We've got a simple YAML configuration file. We tuned it to be very fast. It's a standalone scanner so that you can get it close to your application, so you can rapidly scan all kinds of applications. It could be a traditional web application, a single page application. We scan REST and SOAP APIs with SOAP specs, Open API specs, GraphQL schemas, and so forth. And that scanner sends all of its data back to our backend, our platform, where we provide tools for you to find, triage, and fix issues quickly. And I'll show you a little bit about that when we go to the demo. So to summarize, Datast and SAST have complementary trade-offs. Datast, the advantage of Datast is that it gives you the input-output details that you need to be able to reproduce an attack and understand if you've been able to fix it. The problem is that it doesn't show you anything about the code that you're working on. SAST has the opposite set of trade-offs. When it runs, it'll show you a ton of vulnerabilities. Not all of them are real vulnerabilities that are going to be expressed in your code or expressed in your runtime. So Datast excels at that. Where SAST excels is at showing you where exactly in the code the problem is. And putting those two things together gives you a really powerful new tool. So all of the cons of those two different approaches drop away, and you're left with these huge advantages. So with the Datast part, you know exactly where to focus because anything that it finds is a real thing that is really expressed in your runtime application. And with SAST, you can accelerate your fixes because in addition to the input and output information you need to be able to reproduce the problem, you've also got access to the code base and exactly where in there those problems are. And so you've got a way to quickly zoom in and know where to start to fix those issues. And all of that together really streamlines your workflow. And speaking of streams, you know, the best way to watch a fly fishing tournament is a live stream. Okay, I was told that I needed to add a dad joke, so I'll be here all week. Thanks. Okay, let's jump to the demo. Thank you for your patience. Okay, hopefully you can see my screen, and I've got social fonts here so you can see everything. So what I'm showing you is code base for an application we call Node Express. It's a very simple application written in Node Express, and we've got a search field in it, and you can search for some items in a database. And let's say I just added that search field to my code, and I want to commit this code and open a PR for it. I've also got a StackHawk configuration. So this is what our configuration file looks like. It's very simple. You can add more to this. Obviously, we've got tons of features you can add, like authentication to your application, exclude paths, include paths, light up different types of discovery modules so that we can discover the full extent of your application and get a good deep scan. We've got that automated in GitHub Actions using this workflow. So GitHub Actions is a nice CICD system and makes it very easy to automate things like this. So here's all it takes to automate Hawk scan in CICD. It's a couple lines of YAML again. We've also got a workflow for CodeQL. So CodeQL, this was a push button install. It suggested this workflow for me. And so every time I push new code or open a new PR, it's going to run through CodeQL and analyze my code as well as running the Datast scan with StackHawk. Okay, so one thing I'd like to do is when we have scan results, we can cause the build automation to fail my scan. So I will go ahead and set that up here. Real simple. Light up the failure threshold. Let's say that for any new high severity issue, I actually want to fail the scan. I want to complete the scan, and I want to send all that scan data back to our platform, which I'll show you in a minute. But I want the build to fail so that I, as the developer, get immediate feedback when a new high severity issue has occurred. And I can get past this in a number of ways. Number one, by fixing it, but also by triaging it. And I'll show you that in a moment. So I'm going to save this. And I'm going to commit it and push it. And that's going to kick off code build, which is going to run through the build and unit tests. It's going to do a CodeQL analysis, and it's going to run Hawk scan against it. But just to show you a little bit more about this, I want to show you what it looks like to scan this locally as well. I can kick off both scans at the same time. So I'll run a Hawk scan locally. I've got this application running locally. It's listening on port 3000 locally. And if I come out here to my browser, I can show you what this app is all about. This is my new feature that I added. Let's search for item number 1. I get item 1, and it's a really good item. You should check it out. So the scanner, when it starts up, reads through the configuration file, connects back to this Hawk scan or the StackHawk platform. It starts to crawl the site and discover all of the endpoints that are available. Once it's crawled it and discovered all the endpoints available, it sends all of the tests to each of those endpoints. And then in the end, it gives us a little report of all of the vulnerabilities that it's found. We got some good ones here: SQL injection, cross-site scripting, and a couple others. So that's just a summary though, and the real results are back here on the platform. But I want to point this out. So this is what the pipeline is going to find. There's been an error. We've got two findings with severity greater or equal to high. And that's these two up here. And that fails the build. So if I say echo my exit code, it's not 0, so it's going to fail that build step. And that's what we should see in GitHub Actions when we check back on it. All right, so I want to check on my scan results. So let's click through on this link. Stand by. Sometimes it takes a moment. All right. Demo gods. That's how it works sometimes. Oh, I think I'm in the wrong account here. That's my problem. All right. Scan results. Vulnode Express. This is my most recent scan. So take a look at these findings. So we've got SQL injection and cross-site scripting, just like you saw from my console. I think we've also got results from GitHub here. So when we click into one of these scan results, now to continue the developer story, let's say this was a PR. The PR failed because this build step failed. I was drawn into the console logs, found that link to these scan results. And that's how developers get immediate feedback when new vulnerabilities are found. When I drop into these scan results, we don't assume that the developer knows everything about security vulnerabilities. So we try and explain it to them. Here's what this is about. Here's how you can fix it. Here are the risks if you don't. And we give them some tips on how to resolve this for various platforms or for various languages and frameworks. And remember, the reason we do that is because we can't see their code. So we're not sure what language they're writing it in. We're trying to give them as much help as we can regardless. We also have the input and output data. So this is the request that the scanner made, and this is the response that it received that indicates to the scanner that there's a problem here and a vulnerability that needs to be addressed. This is a real issue. Oh, look, there's also a GitHub CodeQL integration. So by integrating these two tools, now we've got another critical piece of information, which is, where is that problem? Where should I, the coder, go to resolve this issue? Click through to that, and you can see that this line is the problem line. And the problem here is that this search text has not been checked for escape characters that could be used by a malicious actor to escape out of that SQL query and maybe issue another SQL query or some other sort of injection attack. There's more information. So we can click out to the full code analysis results. And here we see, okay, we've got this database query built from user-controlled sources. It's a high severity issue on their side as well. They point to the same line of code and the search text. They provide a little bit more context as well. So we've got a user-provided variable that we're pulling in from that search field that I showed you earlier. And this utility has not found anywhere where we've tried to take that input and make sure that it conforms to our sandbox pattern. So we're not checking for single quotes, for instance, or semicolons that would escape out of that SQL query and allow a malicious user to inject their own query. This is incredibly valuable information for a developer to work with. So again, we've pointed out with the Datast utility that this is a real issue in the running code because that scanner was operating against your running code. And we're showing you where in the code base through CodeQL, where exactly that problem is. That means you know what to prioritize from Datast, and you know exactly how to get started fixing that with SAST. And just to circle back on GitHub Actions, I wanted to show you that this build failed, technically, because there was a new high severity issue. And so in the run hawk scan step, GitHub says, yeah, that build step failed. And we see the error message here, and we can link back to the scan results there. And I also said that you could triage issues. So 9 times out of 10, a developer from this point is going to know exactly what the problem is. They've got all the evidence they need, input, output, lines of code, and they just wrote this stuff. So they're in the perfect place to fix it, and they usually will. But if for some reason they can't, they can also triage these issues. They have a number of options that they can choose from. They can send this to Jira, call it a false positive, which we probably wouldn't do in this case, nor would we accept this risk in this case. But sometimes you might. When we send it to Jira, you can fill in all of this valuable information that helps the next person to come along, really get into the context, and link back to these scan results so they get all the same information that this developer did, so they can quickly resolve that problem. While I'm in here, I want to show one last thing, which is sort of the application security engineer's view that they find useful. So from this page, the applications page, we've got a view of scans over time and what our security profile looks like. So you can see if your scans are trending up or down. Do we have more vulnerabilities now than when we started, or are we starting to work those down? And if I had triaged items, you'd see a gray line down below this x-axis. So what this bar graph is showing you is every scan that we've ever run. And the latest one is off to the right. Yellow means mediums, green means low security alerts, and red means high. So this is just a great view for application security analysts to come through and audit the work of developers who've been using this system. So that is about that. And from here, I'm going to bounce back to questions and answers. I'd like to open the floor. Nicole, do we have any good questions out there?
We do. We're going to kick it off with a classic, a great one. I'll give this over to you, Zach. What is the benefit of Datast over pen testing?
So pen testing is still valuable because there's really no substitute for a human going in and looking at an application and being crafty about how to attack that. Sometimes they can find really unique and innovative ways of attacking an application. And they can also take a look at other assets that you may not have thought about beyond your applications. But our feeling on that is that you should still run Dast in your pipeline and SAST. You should stay on top of security issues in a continuous fashion. And then when it comes to pen testing, you can provide all the reporting and all the data from those tools to your pen tester to give them a head start so they can go work on the hard stuff.
Great.
Yeah, and I think, sorry, just to add to that, you know, you can do a lot more faster when you use automation. And because we'll take all of your specs as well as any potential isolated seed paths you have, and we're working on the ability to also take in postman collections, we can make sure you get a very thorough analysis of all your paths that a pen tester, just based on time and knowledge, wouldn't be able to do.
Sweet. All right, I'm going to punt this one over to Lauren. It appears, so okay, this seems like somebody who's already got at least a free account set up. It appears to only test my guest roles. How do I get it to scan all of my authenticated roles well?
Yeah, great question. We do support authentication. When you go in to add apps, there is an authentication wizard that has support for a lot of popular types of authentication like cookies or tokens. And then we have some pre-established scripts that you can quickly modify for some of the popular vendors like Okta and Auth0. We're adding more authentication scripts all the time. This is something that Zach actually works on quite a bit. So if you have any issues with authentication, we know it can be tricky. Please just reach out to us through the chat or at support@stackhawk.com, and we can help you out with that authentication.
Yeah, and there's a really excellent section of our documentation site. So if you go to docs.stackhawk.com and you look at, I think it's HawkScan, there's a whole authentication section under there. And it's got great examples and scenarios for different types of authentication that you might run into. So everybody does it differently, and we've run into all of it, and we've tried to document as best we can many of those different kinds of situations. So hopefully there's something in there for you.
Yeah, actually, let me see if I can, link this. We have a quick little workshop video that I can send you the link to as well in here. Grab that really quick. And then I think then there's a second question that's looks like maybe a spin-off of the first or that last one we just answered. Are there Bitbucket equivalents?
Oh, can you run this in Bitbucket? Is that the question, essentially?
I believe so, yes.
So yes, you can run it in Bitbucket. Honestly, you can run it in any automation system. So we've tested most of the CICD automation systems and found that it runs just fine in all of them. We've also tested it in a couple of deployment systems. You can run it as a cron job in Kubernetes. You can run it in ECS, Elastic Container Service in AWS. You can run it in build systems in Kubernetes. You can run it in all of the major cloud providers systems, and yes, Bitbucket as well.
Great.
Oh, wait a second. Hang on. I think Michael was asking a different question. So are there Bitbucket equivalents to CodeQL? And I would say yes, there are other SAST utilities out there. And one of them is Sneak Code, and we have an integration with them as well. It'll also work in Bitbucket.
Cool. Michael, if that doesn't answer your question, please feel free to type in and we'll clarify and get an answer for you. Okay, the next one I'm going to send over to you, Zach. I might butcher this, but how is StackHawk correlating Datast findings back to SAST files based on CWE only? Is it doing deeper correlation such that /search? You might have to look at that in the Q&A.
I see.
Okay, great.
Yes, it is actually based on the CWE only. So what you're driving at is it possible that there's a mismatch? And it is possible, but generally in our testing, we found that they match up really well, that they're generally finding the same thing. And we're getting customer feedback as well that it's been a very useful feature for them.
Yeah, when you're testing microservices, you're testing smaller bits of code, so there's less chance that you're going to have a ton of findings in SAST that return that don't match up with what we find in Datast. If you're running this against larger applications, you're going to have more mismatches. But what we found with our customers is that running it on microservices with that CWE ID correlation is really helpful. And because your developers are running it while they're working in the code, they're familiar with those paths and then what code that matches up to. So it's actually really easy for them to go in and know exactly which vulnerability from SAST the StackHawk is referencing. But that is a good question.
Yep.
All right. I'll send this one over to Zach. How long does it take to integrate new vulnerabilities like 0 day?
It takes longer than 0 days, unfortunately, but it's pretty fast. We come out with updates on average once every week or so. Lauren probably has a better understanding exactly our release frequency.
So StackHawk's built on Zap. So as quickly as the Zap community gets tests for 0 day vulnerabilities up, we get them integrated. Sometimes we actually commit those updates ourselves if it's not happening fast enough. So I think with like Spring for Shell, I think we had a fix up within days. or not a fix, but a test. So.
Great question.
Great. All right, I think this one might be for you too, Lauren. Do you support or plan to support certificate-based mutual authentication for system-to-system APIs?
I'm actually going to punt that to Zach.
Sure. So implicit in the question is, do we support that today? And I don't think that we do. We have a locked security store or a certificate store in the scanner at this time. I'm not sure what our plans are for doing that. We haven't had a lot of call for it, but it's interesting to hear that question. It is something that we've thought about before. But yeah, at this time, I don't think we've got it in our plans to address that.
But yeah, anytime we get questions like that, we'll continue to track it. And if we get more questions or more requests for that from customers, we'll look at adding that support.
Perfect.
Balaji with all the last 3 questions here.
Yeah, so first one, does this support running on OpenShift container platform?
Yes, so we can run in any OCI compliant containerization platform, and all you really need is when it's an orchestrated container platform. Generally, what we need is access to the internet and access to your GitHub repository, because when we launch into a container system, unless we're on a local machine and we've got access to your hard drive, what we'll ask you to do is reach out to your Git repo, supply a Git URL. You can stash that in your secrets store, wherever that is, and you can construct a URL to clone your repo into the container so that we can look at your configuration files. We can look at your open API specs, whatever it is that you want to bring to the scanner, and run your scan from there. And it's a great way to go to get that scanner as close to your microservices as possible.
All right, Zach, I'm not sure if you answered this. This is kind of in addition to that question. How does StackHawk support internal applications which don't have access to the internet?
So your application that the scanner is scanning doesn't need access to the internet, but our scanner does. So if you can place the scanner in a place where it can reach both your application and the internet, then we're in good shape. Some people ask if we have an on-premise version of this application, or if we of the platform itself where we're sending all of our data to. And the answer is that we don't have that today. And we don't really have that in our roadmap to create an on-premise version. We really do require that the scanner be able to reach out to the internet and send the data back to our platform. But we understand that a lot of the information that we're sending back could be sensitive. So we take great care to scrub out any sensitive information, such as credentials, usernames, passwords, that sort of thing. Scrub all that information out at the scanner before it ever sends data over the wire to our platform. We're also SOC 2 compliant. We get audited every year, and we do a lot to try and make sure that your data is safe with us.
We also encrypt the data at rest. So
yeah.
Awesome. And then just real quick, just a couple last 2 questions. So does StackHawk support scheduled scanning? And is there Microsoft integrated authentication for web app support?
Yes, we do. So for scheduled scanning, what we usually recommend is, we've got a scanner, you can schedule that however you want. And it turns out that most of the platforms that we are running in have some form of cron job. So basically any CICD system on the planet has cron functionality built into it if you search hard enough for it. Kubernetes itself has cron functionality built into it. There's a cron job specification, and you can put us into that. We have customers that do that today. And of course, on a plain vanilla Linux system, you've also got an actual cron job that you could run. For Microsoft integrated, Microsoft integrated SSO. So that might refer to 2 different things. So we do support SSO authentication to our platform. So if you have a larger organization and you use Azure DevOps or Azure SSO, you can authenticate to the StackHawk platform using that. If you have an application that uses Azure SSO to log into that application, the scanner can authenticate to that in order to get deeper into your application. We don't have an example script for that yet, but it's going to look a lot like scripts that we've already got in place available on our docs site for Auth0 and Okta and some of those kinds of providers. We'll be developing that one soon though, because we've got a lot of requests for that one specifically.
All right. And our final question I'm going to give to Lauren. Do you upload your Datast results back to GitHub, such as the code scanning results, so that the developer can view those in the GitHub platform or pull request?
Yeah, great question. We don't right now. We built this integration independent of GitHub. So if you would like to make a request to GitHub to work with us and start to pull those requests back in to their platform, that would be amazing. We are working on a feature that should be coming out fairly shortly. If by that I mean in the next couple of weeks or so, where you will be able to add PR comments. So you can link back to a scan, you can put scan results in your PR comments so that it's easy for developers when they're sharing PRs or getting code reviewed to share those findings. So that is coming, but the ability to upload the Datast results back to GitHub, we don't have yet. So email GitHub and say, hey, work with this company StackHawk and get their Datast results into CodeQL.
All right, awesome. So that is the end of our questions. We're going to wrap up the webinar with a quick recap. Zach? Oh, you're on mute. Hang on.
Hey, so we talked about shifting security left so you can discover bugs before they ever reach production. We talked about empowering developers to be AppSec force multipliers to help you out on your security journey. And the tools that we're providing them with are SAST through CodeQL and Datast with StackHawk. And when you put those together, we've got a correlation engine that allows you to have improved capabilities for prioritization and remediation. And all of this results in a more continuous application security stance. It will never blow up your roadmap because you're not coming at developers with a big amount of new tickets to operate on after your quarterly scan. Oh, I was supposed to insert a new dad joke here. You know, I had a great one about construction, but I'm still working on it.
Ha.
Thanks. And back to you.
All right. Thanks everybody for your time today. We really appreciate it. We know 45 minutes out of your day is a lot to ask. So if you'd like to learn more, please go to StackHawk.com. We have an on-demand demo there that's about 15 minutes long. You can see Zach answer more questions if you'd like in that demo. You can get StackHawk up and running yourself in less than 10 minutes. So go check it out. And if you have more questions, we have chat on our website or in the application. You can see our docs at docs.stackhawk.com, or we've got a great new help center at help.stackhawk.com. So use any of those resources. And then what's a hacker's favorite season? Fishing season. So thank you for putting up with all of our dad and mom jokes. And we really appreciate your time today and your participation, all the great questions. Please let us know if you have anything else that you'd like to know about at those resources, and hopefully we'll see you on our platforms.
Woo, you'll also get the slides and recording afterwards, so look out for those in your email. All right, thanks guys.
Thanks everyone.
You.